Okay, good morning, everyone. This is a little different than what we did last class. It's the same concept, but what's a little new is that if you look at this system, we don't have a variable isolated. So the first thing we need to do is to isolate a variable. So I'm going to choose to isolate. You always want to look at what's the simplest one to isolate. I'm probably going to take this equation, and I want to get this y by itself. So I'm doing step 1 here. So 3x minus y equals 4. I want to get y by itself, so I'm going to move this 3x over to the other side by subtracting it. So that gives me negative y equals 4 minus 3x. Now, this is a negative y. I can't have a negative y. I need the isolated variable to be positive. So in order to change that from a negative, I'm just going to divide by negative 1. So I'm just going to divide everything over here by negative 1. So this will become a positive. 4 divided by negative 1 gives me a negative 4. And negative 3 divided by negative 1 gives me a positive 3. So I'm really just changing the signs of the other side. Now I have this y isolated. So this right here is equal to y. Negative 4 plus 3x. So I can take that top equation and I can plug this in for y. So I'm going to leave some room here in parentheses, and I'm plugging in this negative 4 plus 3x so I can substitute. So now I'm going to substitute. Then I'm solving for one variable, and then I'm going to plug that variable from step 3 into an original equation to solve for the other variable. So I'm going to simplify this after I substitute. So substitute and simplify. So I'm going to just, this negative 2x can come down. The 5 should distribute. 5 times negative 4 gives me negative 20. 5 times 3x is 15x. Now I'm going to simplify here, combine like terms. So negative 2x and 15x are like terms. So those can combine to be 13x. Bringing down the negative 20 and the 9, and I can add 20 to both sides. 13x equals 29. I don't remember this problem being this ugly. Hold on. Oh, this is a 19. Whoop. I was going to say, I don't think this problem was this ugly. Sorry, I just didn't write 19. Instead, I wrote 9. So it should be 19 plus 20, which would give us 39. So then when we divide by 13 on both sides, we get that x is 3. 39 divided by 13 is 3. I was going to say, I don't remember it being a fraction. Okay, so now that we've solved for one variable, we finished step 3. We need to plug that variable into an original equation to solve for another variable. So I'm going to take this 3 and I'm going to plug it into, I'll use this equation, 3x minus y equals 4. So I'm going to plug in 3 for x. So I get 9 minus y equals 4. And then I'm going to subtract 9 from both sides. I'm left with negative y equals 4 minus 9 is negative 5. Now, we don't want to have a negative y. We want a positive. So you could divide or multiply by negative 1. And you get y equals positive 5. So now your solution should always be written as an ordered pair. 3, 5, because 3 is our x, 5 is our y. Now, just to remember these special cases, don't be afraid of fractional answers. It doesn't mean you're incorrect. Always look for a variable that is easy to solve for. The fewer fractions, the better. So like I wouldn't have tried to solve for y or x here because it would have just been too messy. This was easier to solve for. Check your answers by plugging them into both original equations. So this is what we did on Monday. Plugging the point in and making sure it satisfies both solutions, both systems, both equations. So now we're going to do an example where we get infinite solutions and no solution, like we did last class. So infinite, if I plugged this is equal to x, so if I plugged this in for x here, I'd have 3.5 times, I'd plug in that negative 2y plus 4, and I'd bring down the 7y and the 14. I'm going to distribute this 3.5. And we have a decimal here, so it's okay to use a calculator. So I have 3.5 times 2 is going to give me negative 7y, because that 2 is negative. And then 3.5 times 4 is going to give me 14. I'm bringing down the 7y and the 14 again. Now, negative 7y and 7y are on the same side. They're like terms. And negative 7 plus 7 is 0. So they actually cancel. And I'm left with 14 equals 14, which is a true statement. So this would be infinite solutions because my variables canceled. And when they did, I was left with a true statement. Now this one over here, I have this expression equal to y, so I can take it and plug it in for y in the other equation. So I have 3x minus 11 is going first, right in there for y. And then I have the negative 3x equals negative 13. So now I have 3x and negative 3x on one side. Those are like terms. Those cancel or add to be 0. I'm left with negative 11 equals negative 13. That's false. Those do not equal each other. So there is no solution. So this is just a quick review. The only thing that's a little different from today in this problem is learning to isolate this variable on your own. Okay. If you need some help with isolating variables, there will be tons of this on an IXL you're doing today. So get the practice you need. All right. Have a great day, guys.